Hi guys, welcome back to our channel. So for today's video, we will about to show you our performance on our laboratory experiment 6 entitled Parallel Connected Series. In this activity, our objective is to verify the principles that governing resistances which are connected in parallel. Our materials is PhET Simulator Circuit Construction Kit DC.
For this activity, we were tasked to do our sixth laboratory experiment which focused on parallel connected resistances. The first thing we did was to watch the demo video before proceeding to divide the individual tasks. Then, we constructed a parallel circuit using PhET Simulator Circuit Construction Kit DC. The circuit included the wires, battery, resistor, switch, an ammeter which will measure the current flowing in the circuit, and 2 voltmeters to measure the voltage.
The group decided to set the voltage of the battery at a constant of 9 volts. Next, we determined the value of its voltage. In obtaining the total voltage, we connected the probes of 1 voltmeter to the positive side of the battery, and the other to the end of one of the ammeters. All of the data about the resistance, current, and voltage for trial 1 to 3 were gathered in the table. Lastly, we answered the discussions, observations, analysis, conclusions, and submitted the laboratory experiment before the deadline.
These are the diagrams of our constructed parallel electric circuit for trials 1, 2, and 3. And these are the diagrams of the measured total voltages for each trials.
Can be found on the first column. The R sub 1, the R sub 2, and the R sub T can be found at the second to the fourth column, while the I sub 1, I sub 2, and I sub T can be found at the fifth to the seventh column. Lastly, the V sub 1, V sub 2, and V sub T can be found at the 8th to the 10th column. Trial number 1. The R sub 1 is 11 ohms, the R sub 2 is 22 ohms, the R sub T is 7.33 ohms, while the I sub 1 is 0.82 amperes, the I sub 2 is 0.41 amperes, and the I sub T is 1.23 amperes. Lastly, the V sub 1, the V sub 2, and the V sub T has the same answer of 9 volts. In the second trial, the R sub 1 is 14 ohms, the R sub 2 is 25 ohms, the R sub T is 8.97 ohms, while in the I sub 1 is 0.64 amperes, the I sub 2 is 0.36 amperes, and I sub T is 1 amperes. And lastly, the V sub 1, the V sub 2, and the V sub T has the same answer of 9 volts. In the last trial, the R sub 1 is 17 ohms, the R sub 2 is 28 ohms, and the R sub T is 10.58 ohms, while in the I sub 1 is 0.53 amperes, the I sub 2 is 0.32 amperes, and the I sub T is 0.85 amperes. Lastly, the V sub 1, the V sub 2, and the V sub T is 9 volts.
For computations, to compute the total resistance in a parallel connected resistor, the following formula will be used. 1 over the total resistance is equal to 1 over resistance 1 plus 1 over resistance 2. In trial 1, the value of R sub 1 is 11 ohms, and the value of R sub 2 is 22 ohms. We use the formula 1 over the total resistance is equal to 1 over 11 plus 1 over 22. We cross-multiply the total resistance and we turn the fraction into a whole number, the 1 over 11 plus 1 over 22, so that it will be easy to divide. And we came up with the total resistance is equal to 1 all over 1 over 11 plus 1 over 22. So the total resistance in trial 1 is 7.33 ohms. In trial 2, the R sub 1 is equal to 14 ohms, and the R sub 2 is equal to 25 ohms. We use the formula 1 over total resistance is equal to 1 over 14 plus 1 over 25. By using the same procedure in trial 1, we got 8.97 ohms as the total resistance in trial 2. In trial 3, the R sub 1 is equal to 17 ohms and the R sub 2 is equal to 28 ohms. The value of total resistance in trial 3 is 10.58 ohms.
For the discussions, to verify the principles that governs the parallel connected resistance, we still use the same simulator, which is the PhET Simulator, to construct a parallel electric circuit. A parallel circuit contains several branches, so that the current divides and only part of it flows through any branch. The characteristics of a parallel circuit are as follows. A parallel circuit has two or more paths for current to flow through. Voltage is the same across each component of the parallel circuit. Individual resistance diminished to equals a smaller total resistance rather than adding to make the total. The total circuit currents through each path is equal to the sum of the individual branch currents that flows from the source.
The next part is the observations. Using the FET simulator, we have observed that we need to place each resistor in its own separate branch so that it can be called a parallel circuit. The presence of the branch lines means that there are multiple pathways. When one branch is removed, the other branch would still have current flowing through it because the circuit is still complete for the other branch. In addition, we have observed that the electrons divide between two branches of the circuit until they reach a certain point where they can join together again. Based on the table, we have observed that by using the formula 1 over the total resistance equal to 1 over resistance 1 plus 1 over resistance 2, we can determine the total resistance of each resistor. For the current, we observe that each resistor has different current values because in a parallel circuit, they have different current requirements. Also, the value of the overall current is determined by the value of the individual currents. Thus, the greater the individual current values, the greater is the overall or total current value. For the voltage between the parallel resistors is the same throughout each trials.
Procedure for the parallel connected resistances is almost similar to the procedure for the previous laboratory experiment, the series connected resistances, but the results in table are somewhat different. Based on our analysis, as we set the R sub 1 and R sub 2 in an increasing manner throughout the multiple trials, the total resistance in each trials is also increasing. However, the total resistance have smaller values as compared to the R sub 1 and R sub 2. As we can see in the table earlier, wherein the trial 3 has the highest value for R sub 1 and R sub 2, which is 17 and 28, while the total resistances is equal to 10.58, in which it is lesser as compared to the individual resistances. Next, as for the current values, the results were based from the emitters in the FET simulator. Unlike the resistance, the given values are seen to be in a decreasing order for each trial as seen from the table earlier. Furthermore, as the current decreases, the resistance increases. This can be seen in the table wherein trial 1 has the lowest value of the total resistance, which is derived from the lowest value of R sub 1 and R sub 2, which is 11 and 22. Whereas the total current for trial 1 is equal to 1.23 amps, derived from the highest I sub 1 and I sub 2 value of 0.82 amps and 0.41 amps, thus having an inversely proportional effect with one another. Lastly, all the values of the voltage had a specific value of 9 volts all throughout the 3 trials, concluding that the said value is constant.
In conclusion, the principles in a series connected resistances differs from the principle in parallel connected resistance. If one of the parallel path is broken, the current would still continue to flow in other paths. The total resistance in a parallel circuit is not equal to the sum of the resistors, but rather the total resistance in a parallel circuit is always less than any of the branch resistance. Each resistor connected in parallel have the same voltage throughout the circuit. The current entering a parallel combination of resistors is equal to the sum of the current through each resistor in parallel. We concluded that all these principles were evident in all 3 trials using FET simulator. The laboratory experiment is successful because we verified the principles that governs resistances which are connected in parallel.